In this video, we're going to really be looking at some linear inequalities. So you should have some of this in your memory bank. We're really just bringing it to the forefront so we can start looking at systems of inequalities. But first, we really just need to look at these just straight up linear inequalities. So first, we want to figure out what is an inequality. So it's similar to an equation. And really remember, a linear equation just has an x and a y. It's just kind of the equations that we've been looking at are linear equations. And I always abbreviate equation with EQN, but it has an inequality symbol instead of an equal sign. And we'll look at, we kind of need to remember what those are, and we'll look at those in just a second. So a solution to a linear inequality, right? So our solution to our linear equation was a point, that x and y, that made it true. Okay, so our solution to a linear inequality is all of the ordered pairs that make it true. And we're going to be looking at solving these and also graphing them. So here's our first example. First, we figure out, is this ordered pair a solution? So what we want to do is we want to go and put those x and y in for our x and y in the inequality and kind of solve and simplify. So here I've got an x and a y. So I've got 2 times my x that I'm given minus 3 times the y that I'm given less than 15. Okay, so 2 times 2 is 4 minus 15 less than 15. Is this less than 15? Yep, it is. I don't even have to continue solving it because I know if I take 4 and I subtract 15 from it, I'm going to be less than 15. So I can stop there and just say yes. It's kind of cool because I can actually skip a couple steps to make it a little bit easier. Okay, so let's try this point. So I've got 2 times a negative 1 minus 3 times a negative 7 less than 15. Well, 2 times a negative 1 is negative 2 minus a negative 21 less than 15. Well, if I'm adding 2 plus 21, that is not less than 15. So let's try 3 and 4. So 2 times 3 minus 3 times a negative 4 less than 15. So 2 times 3 is 6 minus a negative 12 less than 15. Well, I see I would end up adding, so no, this is not going to fit in there. So now you can go ahead and try 0, 0, 2 and see if that point actually fits in the solution of this linear inequality. Okay, so now we're going to look at graphing these inequalities. So when we graph it, we show all of our possible answers and all of the points that are solutions. So our first step is we want to put our inequality in slope-intercept form, right? And that's going to be y, and instead of equals, it's going to be some inequality symbol, and then mx plus b, okay? So the only thing different that we're looking at here is it's some inequality symbol instead of our equal sign. So if, remember, we multiply or divide by a negative number, the direction of my sign has to switch. Okay, so I have less than or equal to, I have greater than, and I have greater than or equal to. Just a reminder of what those symbols could be. So then we're going to graph the line. So first thing, I use a solid line, right? So just a straight up line if I've got less than or equal to or greater than or equal to. Okay, so that equal to piece underneath tells me that I have to have a solid line. So if I don't have those, I use a dotted line. So that's just for less than or greater than. So I would dot my line. So something like this. Okay. So then I'm going to shade. So we put it in slope-intercept form first. Then I graph the line piece, either a solid line or a dotted line. And then I have to shade one of the regions. So I'm going to shade above the line, right? And so how I always want to think about it is if my pen or my pencil is touching the line, above would be just anything if I move my hand up. So above is going to be greater than or equal to. Okay, so then again I would shade below for less than or equal to. And there's a way that we can double check once we get that done. So let's look at an example. So here's our first example. So first I notice this is not in slope-intercept form, so I want to get it there. So I subtract my 2x from both sides. So I've got negative 3y is less than negative 2x plus 15. So now I'm going to be dividing by a negative 3. When I divide anything by a negative or multiply by a negative, I'm going to switch the direction of my symbol. So I'm going to go ahead and do that first. So now I have y is greater than. A negative divided by a negative gives me a positive, so 2/3 x A positive divided by a negative gives me a negative, and that would be 5. Okay, so now I can go ahead and start graphing this. So I see that I don't have that equal to part, so this is going to be a dotted line, not a solid line. My y-intercept is at -5, so I still do that, and I have a positive 2/3 slope, so I go up 2 and over 3, and up 2 and over 3. Okay, so then I know it's a dotted line, so I'm going to make my line dotted, and it's greater than, so I'm going to shade above my line. So one way that we can always double check is you pick a point where you've shaded. So I generally like to pick 0, 0 because it makes things go away. Okay, so I see that 0, 0 is in my shaded spot. So I'm going to plug in 0, 0 for this in my equation. So I've got 2 times 0 minus 3 times 0 less than 15. So I end up with 0 minus 0 is less than 15. Yep, that is a true statement. So I know that I've shaded on the right side of the line. Okay, so now let's go ahead and graph a couple more examples, and then I'll let you work on the examples kind of on your own, and I'll post the answers for you. So first thing I notice in this one is it's already in slope-intercept form, so I can go ahead and graph it. I see that I don't have an equal to sign, so it's going to be a dotted line, and it's greater than, so it's going to be shaded above. So I'm just going to give myself those couple of keywords, okay? So I'm going to go ahead and put my y-intercept there, so 1, 2, 3, 4, 5, and my slope is a positive 1/3, so I go up 1 over 3. I remember, and I wrote down that I needed a dotted line, so I'm going to dot my line, and it's shaded above. So I go ahead and I shade my graph above. So this shading tells me that every point within that shading will work in this equation, in this inequality. Okay, so now let's try example number 2. So here I see I have that equal sign, so it's going to be a solid line, and it's less than, so it's going to be shaded below. So I start with my intercept at -1. I have a slope of -2, which means I go down 2 over 1. It's a solid line. So let me see, we're going to use a ruler in reality, but I don't have one right here. So there's my line, and it's shaded below. So I see if I go to my line and I go down, it's going to be shaded down here. So I can always pick a point down here and test it by putting it back into my inequality. So here are several more for you to try. Let's go ahead and try this example number 6, since it's not given to us in slope-intercept form. So the first thing I want to do is I subtract my 3x from both sides. So I have 2y is less than a -3x. Well, now to get y by itself, I divide by 2. I divide by 2. Since it's a positive number that I'm dividing by, I leave my symbol the same way. So now I've got y is less than a -3/2 x. So what that tells me is that it's a dotted line, and since it's less than, I shade below. So I don't have a y-intercept here, so I know it would be at 0. I've got a slope of a -3/2, so 1, 2, 3, and I go over 2. It's a dotted line, and it's shaded below. So I can go ahead and shade in the area that would be my solution set, or all of my possible answers. So then there's just a couple more examples for you to walk through. I will have the answers posted for you, so you can double check that you're doing these inequalities and these graphing, that's the important part, the graphing, correctly. So let me know when you get stuck or have any questions.